Hello everyone, welcome back to my YouTube channel, The Blazing Sun. This is the second session of the complete Python fundamentals from basics to advanced playlist. And at the end of this session, I have a special homework question for you. So let's get started. We also need to understand two terminologies such as operators and operands. First, let us see what are operators. Suppose I have two values 2 and 3. I want to add them. So what is the symbol of addition? Plus. Suppose number 4. I want to subtract them. So what is the particular symbol of subtraction? Minus. So these symbols which are used to perform a particular mathematical operation, or you can say any particular operation, these symbols having a particular meaning in a programming language are operators. Now, there is also another term which is operands. What are operands? See, operators were these symbols which were being used to do a particular operation on these values. But these values such as 2 and 3 or 5 and 4, these were the values on which these particular operations were being performed. So they were these operands. So you can say that in a particular statement, let us see a statement which I gave you earlier, product is equals to 3 into 4. This x or multiplication symbol was uh, an operator, while 3 and 4 were the operands, and product was a variable name. Equal to was an assignment operator. So assignment operators are basically operators which are used to assign a particular value to a variable. Now, after understanding what basically uh, operators and operands are, let us understand the types of operators. Types of operators. So there are many types of operators. We will discuss each one of them, but there is a uh, there are some superset of operators, means categories of operators, in which you can divide all operators. Let us first understand them. So first one is unary operator. What are unary operators? See, when we were doing product is equals to 3 into 5, 4. So 3, 4, these were two operands. So we needed two values to perform this expression. We needed two values to perform this expression. So two values were needed to add two numbers or subtract one number from another. We needed two values. But there are some statements uh, in which we only need one value. Suppose you have given, let me give you an example. So unary operator operates on a single value, and the fancy name of that value is operand. I said that unary operators are the uh, operators which operate on a single value. Now let me give you an example. Suppose you have a integer variable such as num equal to -5. Now you want to convert this -5 into a +5. How will you do this? You will say num is equals to minus of num, or you could write, uh, yeah, this is the same. Yes, this is the thing. Uh, yes. So in this case, the minus operator is the unary operator because it is acting on a single operand num. Now, similarly, if there was what will this means, what will be the result of this code? The number -5 becomes +5. Now, if the number was 0, there would be no change. But if the number was +5, num is equals to minus of num will result +5 to +5 becomes -5. So this is a simple mathematical unary operator. Now there are other unary operators as well, which we will discuss further. After unary operator, there is something called as binary operator. Binary operators. So these are operators which work on or operate on two values, which are values, or you can call them operands. So binary operators are the operators which operate on two, which operate, just a second, which operate on two values. Uh, the simplest example will be num1 is equals to 10, and suppose num2 is equals to 5. You are saying sum is equals to num1 plus num2. So this will result in 15. So you can see that in any mathematical operation, mostly we require two variables. Uh, in such operations like multiplication, sum, division, in these cases, you need two operands and one operator in between. Uh, this is the exception case of the unary operator. This is the exception. Other than this, uh, most of the mathematical operations are like these. Plus, be it addition, subtraction, division, multiplication. These operators operations are done mostly on first two values, then the result is multiplied, divided, or whatever operation you are doing on another value. What I mean to say is, see, uh, if you are adding, I'm saying num1 is equals to 10, num2 is equals to 5, and I'm saying num3 is equals to 15, and I'm saying sum is equals to num1 plus num2 plus num3. Now what actually happens is, whenever you will do sum, first 10 plus 15, sorry, 10 plus 5 will return in 15, and just 15 will be added to another 15, giving us 30. Actually, summation, be it addition, subtraction, division, multiplication, first they act on two operands. Then, if there is any other operand, the operation will occur again. So these are binary operators. When we will go further into these operators, such as binary, unary operators, we will discuss their types further. Now let us go into third operator, which is ternary operator. As the name just suggests, ternary operator. Uh, from ternary operator, it will look like that it might work on three operands. But the thing is, it needs a condition and on the basis of a condition, it will assign value 1 or a value 2. Basis on if the condition is true or false, it will assign value 1 or value 2. These ternary operators you will be able to understand only after you study if else. So we will understand the ternary operators after conditional statements. Now we will go into subcategories of these unary, binary, ternary operators. We will understand all the types of operators which exist in Python or be it any other programming language. Uh, and then we will see if each of them are unary, binary, or ternary operators. So let us go uh, forward. So going forward, when we are studying the types of operators, now this classification which I will do is different from the previous classification of unary, binary, and ternary operators. Now I will do the classification. So the first operator will be arithmetic operator. Arithmetic operator. These are mathematical operators. The operators which you have been studying since your childhood, these are those ones. Suppose I say plus for addition, minus for subtraction, uh, These two you already knew them, but see, in Python this is a symbol for division. This you might have also known this one. This is also a symbol. This is used for integer division. What I mean to say is it calculates the division and return it into the nearest, not the nearest. Actually, it gives the integer value of the division. I will explain it further. Integer division. Then there is ast asterisk sign. This is for multiplication. Multiplication. After this multiplication symbol, we have a double asterisk for this is for uh, you can say exponentiation, or you can say a raised to the power b for calculating power. A raised to the power b can be calculated through this exponentiation. And the last one, yes, the last one would be modulo operator. This is called modulo operator. This is a very useful operator used to calculate the remainder when we are doing a particular division. In case of when we are dividing a divided by b, the remainder can be calculated through this. Means the you will only get the remainder, not the quotient. Let me give you examples of each. Then we will go into our VS Code and do a simple uh, write a simple code to do all these operations. So for plus, I say num1 is equals to 5, num2 is equals to 10. So add will be num1 plus num, just a second, num2, and this will give you 15. If num1 and num2 are 10, num1 is 5 and num2 is 10. So let's say num1 minus num2 will give you minus 5, or num2 minus num1 will give you 5. If you will do num2 by num1, this will give you 2. Now there is one more thing called as typecasting, for which by which you can convert just 2 into 2.00, but we will study it further. Then after division operator, there is integer division. So in this case, uh, let's say we are doing num1, just a second. We are doing num1 divided by num2. Double divided by means the division symbol will be twice. So this will be actually equal to what how it will be calculated. It means that 5, the integer division 10. See, 5 is lesser than 10. So actually when you are dividing 5 by 10, the value will be 0.5. But it gives the nearest, not the nearest, sorry, not the nearest, but it gives the integer value of the division. So in 0.5, the integer value is 0. So it will give 0. After that, we have a multiplication symbol. Let me give you an example. Num1, if it was 5, multiplied by num2. This will give you 50. Now num1 raised to the power num2 will be equal to 5 raised to the power 10. You can calculate it. Then num1, or let's say num2 modulo num1 is equals to, what it actually means is 10 modulo 2. So this will give, no, sorry, 10 modulo 5. And you know the remainder when 10 is divided by 5 is 0. So this will give 0. So these were the mathematical operators. Let us write some code to see how they work in Python. See, these in the way I have written on this screen, this is the way I have written. But you cannot assign values in Python like this. Num1 is equal to 5, comma num2 is equal to 10. There's a separate method, otherwise this will give an syntax error when writing the code. So let me show you how we will assign the values to these variables and do these mathematical operations on them. Let us go through that. Let me make a new file, Arithmetic Operators. .py. The file extension of any Python file is .py. Now let us say, yes, I did not tell you how to take input from the user. So let us say I have a that I will teach you further. Let's say suppose I have a num1. This is my first number, and I am assigning it to, let's say, 7. Now num2, I am assigning the value, let's say 3. So now I want to add these numbers. So I will say add, let the third variable be add, and the value will be num1 plus num2. This is for addition. So what will be the result of addition? I think it should be 7 plus 3, 10. Let us see the result. See, it is printing 10. Now, if I say, let me comment out this for some time. Let me remove this instead. Now I want to subtract. So subtract equals to num1 minus num2. And what will be the result of this? I know 7 minus 3 is 4. So this should result 4. This is for subtraction. Let me see the result. See, 4. Let me run this again. 4. Now I want to check their product or multiplication. It is equal to num1. I told you asterisk sign, then num2. Then I will print product. 7 into 3 is 21. So this should result in 21. See, this was for a multiplication. Now after multiplication we had division. So I can say quotient, instead of quotient I should say division equals to num1 divided by num2. So this will give, this is the division. When I will print the result, I encourage you to try these examples along with me by pausing the video. So when printing the division, 7 divided by 3, actually the quotient is 2, but let us see what exactly it will give. See, it will give 2.333. This is because of something known as implicit typecasting, which happens in Python. Uh, it happens in case of division, as mostly in the case of division. See, it happens in every case, like in addition also. If you will do 4.0 plus 3, it will give 7.0. So this happens because, see, if there's two numbers, 7 and 3, and you will divide 7 by 3. So actually the result is 2.333 and so on. But if you will convert this into 2 instead of 2.33, so there is some loss of data. And to avoid this data, the loss of this data, Python converts the given data type into the nearest or the most accurate data type. Uh, we should say most precise data type. Now, so 7 is an integer, 3 is an integer, but the resulting number is a float. Now, after division, I want to check what will be the remainder. Remainder is equals to num1, and we know that modulo sign or percentage sign is the symbol for checking the or calculating the modulus remainder. So num2, let me print this. Now I am going to run this. So we know that 7 modulo 3 will give an operator remainder of 1, because 3 2 is a 6, so 1 is the remainder. So we should give 1. Yes, we are correct. Now after remainder, what else is left? We have not calculated the uh, integer division, which is equals to num1, then two symbols of the division, then num2. This is integer division. Now let me print this integer division. It is giving me 2. Why is it giving me 2? Because see, 7 divided by 3 is 2.3333 and so on. So the integer part of this 2.3333 is 2. So that's why it is returning me 2. Now after integer division, the last thing is calculating power. So power is equals to, or it is num1, then two asterisk signs, 1 2, yes, num2. So it will result me 7 raised to power 3, which is 247, I think. Uh, yes, 247. So when I will print this power, it should give me 247. Sorry, 343. Yes, 343. 7 raised to power 3, so yes, 343. Okay. 7 raised to power 2 is 49. So 49 to 5, 3. Okay. 343. Yes. After this, This was calculating a raised to power b, calculated a raised to power, which is a raised to the power b. So these were the operations, mathematical operators. You can print these values, uh, print all of their values. Now moving forward, we have more types of or more types of operators to discuss. After arithmetic operators, we have relational operators. Let me write relational operators. You can also call them comparison operators, but the most used name is actually relational operators. But actually, yeah, you can more closely relate them to comparison operators. So what are their types? First one is greater than. This is called greater than, or to remember then you should say is greater than. Then another one is greater than equal to. You should say is greater than or equal to. So in case of greater than, first number a should be greater than b. Then only the equation will be true. But in case of greater than or equal to, the first variable can be greater than the second one, or it can be equal to the second one to give the result as true. Now the third one is lesser than, so you should say it is lesser than. Now fourth one is lesser than or equal to. So this is lesser than or equal to. So in the case of lesser than, first variable should be lesser than the second variable, then only the result will be true. While in this case, lesser than or equal to, the first variable can either be less or equal to the second variable. We will understand all these when we will code them. Now, after this, there are few more equal, equal to. Now, these are double equal to symbols, which mean is equal to. Now, these are used to check whether the first value is equal to the second value, like 5 is equal to 5 or 5. This will result into 10. 5 is equal to 5, but 5 is equal to 10 will result into false. So double equal to symbol is used to check the equality, checks equality. But we have earlier seen that in arithmetic operators we were using a single operator, equal to operator. This is for assigning the values. So this is an assignment operator. We will write it later. Assignment operator. See, double equal to. This is double equal to sign is used for is equal to. Now the last relational operator is not equal to. This is the exclamatory mark symbol and then equal to sign is not equal to. So if it checks whether the first variable's value is not equal to the second one. Suppose they are same. Suppose the values are equal, so it will result into false. And if they are different, means their values are different, so it will give as true. Let me give you a few examples. 5 is lesser than 3. This is false because 5 is actually greater than 3 and not lesser than this. 5 is lesser than or equal to 3. This is also false. 5 is equal to 3. This is again false. But 5 is greater than 3. This is true. 5 is greater than or equal to 3. This is true because either one of the conditions should be correct. Either it should be greater than or equal to. 5 is greater than or equal to 5. This is true because 5 is equal to 5 and any one of the conditions should be satisfied. 3 is not equal to 5. This is again true because 3 is actually not equal to 5. 3 is not equal to 3. This will result in false. Lesser than is covered, lesser than equal to is covered, greater than equal to greater. Yes. Uh, yes, we are done. Now I am going to write the code for all of these. After arithmetic operators, let me make another new Python file. It would be relational operators. .py. Now I will teach you how to take input from the user. So because every time you cannot write the code on your own, means you cannot take hard coded values from your own. Because see, the actual programs that you will write in the future, you will need to take some or the other input from the user. Then only the program will be not static to a particular value. It will be dynamic according to the value entered by the user. So let me first explain you that how to take the input. I think, yes, I'm writing a note to take an input from the user. We use the input function. It is a predefined function in Python. What are predefined functions? They are actually the functions which were written by the developer of Python when that particular when Python was being developed. So you do not have to write uh, this function on your own. They are already built in to make your work easy. And how do we do that? Suppose I want to take num1. See, it is a number, or I say it is an integer value. So how I will take input? See, I want to store the value in some variable. I have called it num1. Then I will write input and then curly braces. If I will uh, take input like this, it would be okay. But since I am taking an input as an integer, I need to write int outside this, and then I have to write this input within in this integer int function. Otherwise, while performing any arithmetic operator on this, it will give an error. Why it will give an error? Uh, I will tell you. This is the way how to take input, takes an integer input. Actually, it does not take an integer input. It takes an input and then converts it into an integer. Now, you can also say that if you want to display some message to the user while taking an input, what you can do is same thing, integer and input you will do, but within this input you will give a message, and message is a string, so you will say enter second number. This like this you can give an any message and then close all the braces. Don't forget to call all the braces, otherwise the uh, you will get a syntax error. Uh, this is another way to take the input. Now there is one more note that input function by default takes a string as its input. What I actually mean by it is that if you will just write input and not convert it into integer, so the actually the what will be stored in num1, it will be a string. Suppose you will give the input as 5, so num1 will actually get 5 in uh, inverted commas or quotes, whatever you call them. You will get 5 inside quotes. So when you will perform any operation such as addition and subtraction, you will either get an error or a something will happen which is not expected by you. Okay, so we will convert this into an integer. Now let me write a code for these relational operators. In this case, I will take input from the user instead of using the hard-coded values, just like these. These are fixed values, 7 and 3, but now I will take values from the user. So I will also give a message to the user, because uh, user experience should also be good when he or she might be using our code or our program for a particular work. So I will say num1, I'm assigning the value equal to, I will convert it into integer uh, because input by default gives a string, assigns it into a string. Uh, what I will do is int, or first let me take an input, and within the I will give a curly braces. Then within the curly braces, I will give a message in double quotations that enter first number. Now I will move to next line. But wait, I forgot to convert this input, which is a string, into integer. Let us see what will happen to it in future. Num2 is equal to input enter second number. Okay, so Now I will print their sum, not sum actually. I will print whether these values are greater than, less than, what is the relation between the values. So I will print num1 is greater than num2. I will print the result is greater than uh, uh, I will print the result of the relational operator, which in particular is greater than. What do you think will be the output when, let me give some input. See, it is asking me the first integer. Let's say the first integer is 12. Now the second number it is asking me, so let me say it is 5. So it will calculate either 12 is greater than 5. So 12 is not greater than 5, so it will result false. See, it gave the result as false. Uh, I should give a space here to make it more clear. Mm, just one sec. Now I will print. See, why did I get a Boolean value here? Suppose it was 12 and 5. Why it gave me 12 false? Because the result of any relational operator actually is a Boolean value. Uh, the Booleans, there are two values in case of Boolean, true and false. So if the condition is true, it will give me true. Otherwise, it will give me false. So this condition was not true. That's why it gave me true. So num1 is greater than 2. That's why it gave is not equal to is not greater than 2. So it gave me false. Now num1 is greater than or equal to num2. When I will give this, just a second, let me comment this. So if I will give the input 5 and 5, it will give me true, because 5 is actually equal to 5 and any one of the conditions should be correct. Let me comment this, and yes, this was for is greater than or equal to. Now the other one is num1 is less than num2. This is for is uh, lesser than. So let me give an input. Let's say first number is 13, another one is 14. So it is giving me true because 13 is actually lesser than 14. Let me comment this. Now I will print the result of num1 is lesser than or equal to num2. So this is lesser than or equal to. So this will give true in either case, whether first number is lesser than second number or it is equal to the second number. Let us say the first number is 14, another number is 14. It will give me true because both the numbers are equal. Now suppose the first number is 13 and the another number is 14. So again it will give me true because 13 is lesser than 14. Uh, Now I will give first number as 14, another number as 13. So this will give me false because 14 is not lesser than 13 and 14 is also not equal to 13. Let me comment this out. Now the next one is whether num1 is equal to num2. Now, when we say equal to, we say is num1 is equal to num2, but always remember that for checking the equality, you need to use double equal to symbols. Is equal to. This is used to check the equality. Suppose the first value is 12, second one is 12, it should give me true because both are same or both the values are equal. The second one is 13, another one is 14, so it will give me false because 13 is not equal to 14. Now if I will give 14 and 13, again it should give me false because both the values are not equal. Let me comment this out. Now the last one is not equal to. Num1 is not equal to num2 is not equal to. It is used to check whether the first one is not equal to. Yes. Suppose the first value is 12, another one is 12. So 12 is actually equal to 12. So it should give me false because 12 is actually equal to 12, and we are checking whether they both are not equal to. Now I will say 12 and 13. So 12 is actually not equal to 13, so it should give me true. Yes, it gives me true. Now we have completed the relational operators. So there was one more note which I want to add in this slide. Just a second. Uh, it was a very important note, and we often make mistake regarding this note. This is a very important note. Note double equal to symbol is used to check the equality of two variables, while and just double equal to is actually a relational operator. Uh, while equal to symbol uh, equal to symbol is an assignment operator. Is an assignment uh, second is an assignment operator used to assign a value to a variable. So if you are using ones equal to symbol, it has a particular uh, is a it is having particular functionality, means it is used for any other reason. The other reason which it is used for is assigning the value of a particular value, assigning any other value to a variable, while double equal to symbol is used for relational operator. It is a relational operator and it is used to check the equality of two variables. So don't get confused between these two. Uh, Moving on, this is an important one. Now, after we have completed arithmetic operators, relational operators, and we have understood how to take input, After inputs, rational arithmetic operators are done. We have understood assignment operator. See, equal to double equal to sign is also only an assignment operator. No, sorry, what did I say? Uh, Double equal to symbol is a relational operator. It is used to check the equality of two variables, and a single uh, equal to symbol is an assignment operator, and it is used to assign a value to a variable. The term I used is assignment operator. Assignment operator. So actually, there's only this one is the assignment operator. Okay. Now let us go to another operators. The third operators are logical operators. And they actually work on Boolean values. How do they work on Boolean values and what they actually are? Let me explain you. See, there are three logical operators, and uh, and gives true when all are true, otherwise it gives a false. We will understand this while doing code, but let us let us understand this theoretically as well. After and, the other operator is or. True if any one, if at least one is true, false when all are false. And the third operator is, third logical operator is not. Not of true is false, and not of false is true. Uh, Let me explain you. See, suppose there would be, when you will study if else, these logical operators, these relational operators will come in very handy. Uh, so at that time you will be able to understand them more clearly when we will study the conditional statements. But uh, what you need to remember is and when we are using and. So the result of an expression containing and means there is only and between the operands. It will be true when all of these operands individually are true, and it will be false even if a single one of them is false. Uh, if there is or between each one of the operands, the result of this whole expression will be true only if any one, at least one, there can be multiple ones, multiples also, which are true, but at least one should be equal to true, while it will be false. The whole expression will be false if all are false. Uh, Suppose there is a true or true or true. So the result of this is true, true or false. This will again be true because there is at least one true. But if there is false or false, so the result will be false because false is the is the only one that is existing in that expression, and true is actually not in that expression. Now, let me tell you what actually not is. Not is what do actually I actually mean by that is it will convert true into false and false into true. So uh, it is making it is converting into its mirror image, you can say. So if an expression is true, if you will add not in front of that, it will become false. And if the expression is false and you will add not in front of that, it will become true. Let us write the code. We are doing logical operators dot py. Uh, what I will do is I will print the result. See, suppose I am saying print true and true. I will take two values. True is the first value, while this true is the another value. This true is another value. Now, because both of the trues are actually true, what I mean is both values are true, so this should give me true. Yes. But if I make any one of them as false, this will give me false. Now, because for true, all the getting, if you have you are using an on AND operator, so for the result resultant to be true, all the operands should be true. All the conditions should be true. Now, when I print true or true, this should give me true because any one of them should be true. This will give me true. Yes. Now, if I'll change them, now if I'll make it into true and false. So this should give me a true again. Sorry, not and, it should be true or false. So it should give me true again because for or any one or at least one should be equal to true. It is giving me true again. Now suppose I say false or false. So this should give me false because for getting true while using or, at least one of the values should be true, but in this case, none of the values is actually true. Now, let us see what is actually how not works. If I am writing not true, so what I said it is not converts the true into false. So this should result into false. Yes, it is. Now, if I will write not false, so not should convert this false into, means not just actually I mean is not false, this whole expression should become true and the result will be true. Yes. This was all about logical operators. Now, the fourth types of operators are bitwise operators. Bitwise operators. Speaking of bitwise operators, they work on uh, they work on binary forms, or I should actually say they work on individual bits of numbers. Uh, the binary operators work on individual bits of numbers. What I mean to say is, see, there is something known as uh, there are different number representations, uh, different number systems, such as decimal number system, uh, decimal number system, octal number system, hexadecimal number system, and then we also have this binary number system. So what happens is, suppose you give a number as an input, or you assign this particular number into a variable, then you are uh, doing a particular bitwise operation on this uh, on that value. So that particular integer will, and then the operation will happen on that particular each and every bit of that number. Now, what I actually mean is, let us understand what are the types of binary operators, how many they are. The first one is bitwise, and it is denoted by ampersand symbol. It is used to perform used to perform AND operation uh, operation on bits. What I mean to say is, let me give you an example. Suppose there is a variable num1 equal to I say 5, and I am writing num2 is equal to uh, is equal to, let's say, 6, and I am saying bitwise I am assigning a variable name bitwise, or I should say I am assigning a value. Let me call this new variable as, let's say, I am giving it a name as num3, and I am saying it is equal to num1 and num2. So what actually will happen is, see, the Binary representation of 5 is 1, 0, 1, 1 plus 4, because 1 plus 4 is 5. And the binary representation of 6 is 1, 1, 0, because the 4 plus 2 is 6. Now, when we are doing the uh, bitwise AND operation, so what actually will happen is you can add these bits, not actually add these bits, what I should say is uh, bitwise AND operation will happen between them. So 1 and 0. 1, in case of if you have studied earlier what is bitwise AND operation. So for returning 1, both bits should be equal to 1. Since first bit is 1 and second one is 0, so the result will be 0. Now, moving here, the first bit is 0 while the second one is 1. So the result will be 0 because both should be 1 to get 1. Now, in the third bit, both of them are 1. So this will result in 1. So what exactly is this number? This is 4. So num3 should actually store 4. Let us run a small code for this and see whether we are correct or not. Bitwise operators dot py. I said num1 was 5 and num2 was 6. Now num3 I am saying is num1 ampersand num2. Now I am printing the value. I should get a 4 num3. Now this is how binary AND works. We might study them more further in case we get any question in the future. Now the second bitwise operation is bitwise OR, and its symbol is this straight line. It is used to perform OR operation on bits. So if you have studied AND or not in your previous classes, you might know that in case of this OR, it results true even if not true exactly 1, even if one bit is 1. Let me tell you. See, I am taking again the same example. Num1 is 5 and num2 is uh, num2 is 6. So I am saying num4. Let's say num4 is equal to num1, not ampersand, the vertical line num2. So we know the binary representation of 5 is 1, 0, 1, and the binary representation of 6 is 1, 1, 0. Now we will do a bitwise OR operation. So 1 and 0. Either of them is 1, so it will result 1. 0 and 1. Any one of them should be 1 to get 1. This is 1, so we will get 1. 1 and 1. Any one, at least one should be 1, so we get a 1. So this is 1, 1, 1. It is actually the 4 plus 2 plus 1, which is 7. So it should actually give me 7 as an output. Let us see by writing a simple code whether we are getting 7 or not. I will print num4 and I am assigning num4 as num1 bitwise OR. The symbol you will get is above the enter key and then num2. Now I should get an output as 7. See, I'm getting an output as 7. The third one is bitwise XOR. Bitwise XOR. It is used to perform an XOR operation on the binary representation of two numbers, and the symbol is let me write the symbol here. The symbol will be this. This is a symbol. Uh, this is the symbol for it. You will find the symbol on the 6. The key which is having 6 on it, you will find the symbol on that. Now, let me give you an example. See, if num1 is, we are taking the same example, 5, and num2 is actually 6. So the binary representation of 5 is 101, and the binary representation of 6 is 4 plus 2, 6. Am I correct? Yes. 1 plus 4 and 2 plus 4. Okay. So when we will do the XOR operation, let's say num5 is num1, and this is the symbol for the XOR operation, num2. So what actually happens in XOR is, XOR actually means exclusively OR. Uh, exclusively OR. What actually it means is, in case of OR, any one of the bits should be 1, or at least one should be 1 to give me result as 1. But in case of XOR, both of the bits should be different to give me result as 1. Let me tell you what I actually mean. See, 1 and 0, these both are different bits, so I will get a result as 1. 1 and 0, both of these are different, so I will get a result 1. 1 and 1, they are not different, they are the same, so I will get a result of 0. Now this is the binary representation of 1 plus 2, which is 3. So num5 should store Uh, 3. Let us see if we are correct or not by running a small code. Num5 is equal to num1, and you will get the symbol for bitwise XOR operator above the 6 key, the key having 6 on it, this symbol, then num2. Now I'm printing the value. I'm printing the value num5. I should get 3. Yes, I get a 3. Now, just like logical NOT, we also have a bitwise NOT. Now, let's go to bitwise NOT operator. Bitwise NOT, and the symbol is this. You can find the symbol above the tab key. So, what exactly bitwise NOT does? It uh, applies a NOT operation on each bit of a number. Uh, the unique thing about bitwise NOT is that we actually only need a single operand to execute bitwise NOT. We have seen bitwise XOR, bitwise OR, and bitwise AND. In these, we required two numbers, num1 num1 and num2. Here also num1 and num2. Here also num1 and num2. But in case of bitwise NOT, we only require a single operand. So you can say that bitwise NOT is a unary operator, while the rest of the bitwise operators, uh, such as bitwise XOR, bitwise OR, and bitwise AND, are not unary operators, but they are binary operators. Similarly, we have seen that NOT operator, the NOT operator is also a unary operator because it required only a single operand, either true or false, to operate on it. Moving back to the bitwise NOT operator, what exactly it does is it applies a NOT operation on each bit of a number. So let me explain you this with an example. Suppose I say num1. Let me take an example. Num1 is num is equal to, let's say num is equal to 10. Okay. So what is the uh, binary representation of 10? It is 10 is 8 plus 2. So 1, uh, 0, 1, 0. This is the binary representation of 10. You can see uh, this is for 1, then 2, 2 plus this is 4, and this is 8. 8. So it is 10. Yes. You can see that. Then what exactly operator does is it applies a not operation on each and every bit. So you can say that ones become zeros while zeros become ones. Actually, this must happen. So let me show you. Not operation is actually inversing each of the bit. Like 1 should become 0 and 0 should become 1. So as per this case, uh, let me say new num. I am creating a new variable called new num, and what I am doing is I am applying bitwise not on num. This is how we apply bitwise not using this symbol. So what should this result? Say 1010 was the binary representation of 10. So I am saying that ones should become 0 and 0 should become ones. So this should turn into, see, this 0 should become 1, this 1 should become 0, this 0 should become 1, and this 1 should become 0. So as per this statement, which we usually hear, uh, this this number 10 should become 1 plus 4, which is 5, because this is the binary representation of 5. So let us see if this actually becomes 5 by writing a simple code uh, in VS Code. Bitwise operators. Suppose, let me comment this everything. Uh, I can just comment the print statement. Okay. So I say, let's say num is equals to, I have taken 10. Now I am saying new num is equals to bitwise not. This symbol you will find above the tab key. Then you will write num. Now what I will do is print new num. Um, and now I will run this program. So as per this, we should get answer as uh, we should get an answer as 5, which we already saw, but we are getting an answer of minus 11. Okay, so we should have got 5, but we are getting minus 11. Why is this so? Why are we getting a different answer than the expected one? Because see, um, this concept, just a second. Yes. This concept is actually true only if the bits of, or I should say, actually the number was if the number was in unsigned form. Now, actually, there are two types of numbers. What exactly unsigned means, I will explain. See, there are two types of binary representations. Binary representations of a number. One is signed, another one is unsigned. Uh, if you want to represent a negative number in binary form, so in this format, you cannot represent the binary representation of a negative number because there's no way of distinguishing a positive 10 and a negative 10. So actually what happens is uh, that unsigned is used to represent only positive numbers, only the magnitude, while the signed ones uh, represent negative numbers uh, as well as positive numbers. So how to make this difference? See, earlier all the examples that I have taken in XOR or and AND operations. So in these I have taken the unsigned operation, unsigned unsigned examples, the numbers which were unsigned. But there is a thing called as two's complement, which occurs in this bitwise note. So this is because when we are doing bitwise note or any bitwise operation in Python, by default, Python assumes a number in its signed form. What I actually mean is that Python sees whether the number is positive as well as negative. It not only considers its magnitude but also its sign. How do actually this happens is that uh, suppose you have written a number, let's say you had written 10. So if this is a positive 10, 1010 would have a 0 before it, uh, like this, a 0 like this. But if it was a negative number, then this number will be followed by a 1. Suppose this was 10, so actually the binary representation would be different, not 11010. There's something known as two complements that happens when doing a bitwise note. So it's too complicated and not actually required so much in Python. So there is a different trick that I want to explain you to calculate this bitwise note. So what actually happens is in Python, if you get uh, the question is how bitwise note happens. There is something known as two's complement. You can You can study about it if you want, but it is not so much needed as per of now. So I will show you another method to calculate the bitwise knot of any number. If I have a number num and I want to calculate, if I have been given a number. Let me take this as an example. If I have a number 10, I took this example earlier, and I want to calculate new num as bitwise knot of num. So how exactly this happens is that in this what exactly is stored in this variable new num. So new num actually becomes, if you are doing this, this will become uh, minus of num plus 1, or you can also write minus num minus 1. So either one of them you can write. What I mean to say is, suppose this was num was 10. So how bitwise knot of num will be computed? You will add 1 to num and then uh, change its sign from positive to negative. Or if it was positive, you will change its sign to negative. So if it was 10, it should become minus of 10 plus 1, which is equals to minus of 11. Or it should become minus 10 minus 1 equals to minus of 11. Either way you can calculate it. I have just taken this minus sign outside of this bracket. Otherwise these both are same. So this is the trick to calculate the bitwise knot of any number. Now let me take another example so that you understand this more clearly. Uh, what will be the bitwise knot of 5? So I told you that it would be minus of the number plus 1, or you can take minus 5 minus 1. It's your wish. So this would be minus of 6. And let me take another example. What would be the uh, bitwise knot of, suppose, 0? So it would be minus of 0 plus 1. This will be minus 1. All these examples which I have taken, all these are examples which I have taken are of positive numbers, or 0 I have also taken. Now let me take last example. This would be, let's say, bitwise not operator on minus 3. So how this will happen is, I have put a minus sign outside, then I am taking minus 3 plus 1, num plus 1, and then I am changing its sign. So this would be, say, minus 3 plus 1 is minus 2. So this will become 2. Now the values I have taken as 10, 5, 0 and minus 3. Now let me show you by running these values in my VS Code, so that we can confirm if we are right or wrong. Let me comment this. Let's say num, I say 7. See, 10 will become minus 11. This we have already seen. And as per my formula, 10 should actually become minus 11. Now, if I'm taking num7 as 5 and I want to calculate, I'm just directly printing instead of storing a value of bitwise not num7. You can also print the value directly by putting uh, the uh, the value in this format using the bitwise not operator and the variable name instead of storing it into new variable. If you do not want to use this calculated value further in your program, so I will run this, and what I should get is let's see, we should get a minus 6. Minus 6. Let's see if we are correct or not. Yes, we got a minus 6. Suppose I want to print, let's say num8. I'm storing it as what example did I take? 0. And I want to print bitwise not of num8. So what should I get is, uh, I already told you, I should get a minus 1. Minus 1 should be my answer. I am getting a minus 1. This is the answer. Uh, Let me comment this. I'm commenting this as well. Now, suppose I want to, uh, I am taking a num9 variable and storing, which example did I take? I took a minus 3, and now I am printing a bitwise not of num9. Actually, I should get a 2. What value am I getting? A 2. Got it? Now you can actually remove these comments so that, yeah, you can print all the values at once when I will share these notes with you. Yes. So all of these values were correct. Uh, these were the correct ones, while this one was wrong. So this was wrong. Now after bitwise not, this was all about bitwise not. Now after bitwise not, there are two operators more in bitwise operators. Um, First one is bitwise, you can say left shift operator, which was this one. This was fourth, fifth. Left shift, and the symbol for this left shift is, you can see there is an arrow key, uh, which is also used for lesser than symbol, you can say, and these two less than symbols together are the symbols of left shift. What left shift does is, it shifts the bits uh, to the left. So if a number was of some format, let's say it was I am saying I am taking a example of uh, suppose a number was num equals to, let's say num1 is equals to 5, and I am saying uh, new num is equals to, then I am doing left shift on num1. So what I will do is I will write num1, then left shift, then I will write by how many bits, by how many number of, I want to say that uh, how many the bits should be shifted towards the left. So if I want to shift all the bits by a single value, means one place towards the left, I will write 1 here, or I can write 2 if I want to shift all the bits towards the left by two values, by two places. So what I will do is, let's take an example by shifting it by one place. So what was the representation of 5? It was 1. Let's say it is 0, 1, 0, 1. So it is 1 plus 4 equals to 5. Yes. So I am shifting uh, the bits, each bit towards left by one place, because I have written 1 here. So what I will do is this 1 will come here, 1. This 0 will come here, 0. This 1 will come here, 1. And a new 0 will come over here. So this number will become 2 plus 8. 2 plus 8 equal to 10. So the new number becomes 10. Actually, you don't have to uh, think it about, you cannot, or I should say, you should not think each time or like this. There is also some trick regarding how to calculate the left shift of a number. So new num can also be calculated by this formula. Suppose I want to shift shift num uh, num1 by n. I want to shift the bits of num1 by n places towards left. So new num is actually equal to num1, then this symbol of left shift, and then n. How can I calculate it mathematically? So you are seeing that when I shifted this 5, uh, each bit of this 5 in its binary format through one, by one place towards left, this number got multiplied by 2. So actually what happens in left shift is the magnitude of the number increases. So what actually happens is that new num, new num this whole, or left is equals to right, so you can write any one of them becomes equal to num1 multiplied by 2 raised to the power n. See, what was n? It was the number of positions by which the bits of the number should shift. So earlier in the example, you can see n was 1. N was 1. So the number should become its double because 2 raised to power 1 is 1. 2 raised to power 1 is 2. So the number should become its double. See, 5 became 10. So uh, let me give you another example. Suppose I wanted to calculate 5 left shift of 2. So what should be its answer? I should get 5 into 2 raised to the power this 2, uh, this 2. So it should become 5 into 2 raised to power 2 is 4. So this should become 20. Now another example I should give you is suppose 7 left shift of 3. So it should become 7 into by the formula 2 raised to the power this 3. 7 into 2 raised to the power 3 is 8. So it should become 56. Just keep this formula in your mind. Uh, this formula. And similarly, keep in mind for the bitwise note. This was a short trick. You can just remember this much. So let us see whether 5 left shift 1 and 5 left shift 2 and 7 left shift 3 have been calculated correctly by us or not, and how to write this in the form of code. Uh, for now, I am commenting everything. Let's say I have num 10 equal to 5, and I want to store, or I can even print. I am directly printing the value of num10, then left shift by, let's say, one place. So I should actually get a 10. Let's see if I'm getting a 10 or not. Yes, I got a 10. Similarly, let's say num11 is equals to, or I want to print 5 left shifted by 2. So you can see that I am using the same variable because its value is equal to 5. So if I am shifting by 2, I should get a 20. Let's see if we are correct or not. See, we got a 20. Now the third example that I took was when the variable was 7 and I wanted to shift it. I wanted the left shift of this number num11 by 3 places. So we show that its answer should be 56. Let's see if we are correct or not. See, we got 56. I'm removing the comments for now, or let them be commented. This was all about left shift operator. Now, similarly, there is another operator which you can guess, I think. It is right shift operator. So this was fifth one. Sixth operator, sixth bitwise operator was right, uh, right shift, and its symbol is this arrow key pointing towards right 2 times. And what it does is shifts the bits towards right. You can take similar example, or I am taking a new example. Suppose uh, let me give an example. I have a num equals to 20 and I want to calculate new num which is equals to this num, and I want to right shift, or I want to shift each of the bit of this number 20 by right towards right by 2 places. So I will write 2 here. So what is the binary representation of 20? It is 1 0 1 0 0. You can see this is 1 2, this is 4. So this is 4 plus this will be 8, this is 16. So this is 20. I am saying shift each of the bit of 20 towards right by 2 places. So this is the binary representation. And what exactly this number is? This is 1 plus this is 2, this is 4. So this will become 5. So you can clearly see that in case of left shift, the number was increasing. It was being multiplied by 2 raised to power something. While in case of right shift, the number is being divided. So when we did right shift by 2 bits, or you can say by 2 places, the number was divided by 4. So you can get a formula that num right shift by n is actually equal to num. You should see that it will be integer divisible division. Why? I will tell you. 2 raised to power n. See, 20 was a even number. So 2 raised to power 2, which is 4. If you are dividing 20 by 4, this will give you 5 and not any decimal number like 4.8 or something. So you have divided 20 directly by 5. But suppose in place of 20 there was some number like, let me give an example. The number was 15. Number is 15 and I want to calculate new num equals to num and two places overwrite by not two places, or you can do two places which would be 2 raised to the power 2 4. So yeah, you can do 4 as well, or to keep it simple and easy to understand, I am doing it by one place. So by the formula what I mean is, uh, by the formula I mean that the new number must become 15, and I am dividing it integer division. So what I mean is 2 raised to the power this number, 2 raised to the power 1. So actually 15 divided by 2 is 7.5, but you will take only the integer part out of it, so it will become 7. This is what I mean, that you will take only the integer part and not 7.5. Let me quote this for you, these two examples for you, so that you can verify them for yourself. I am commenting these lines as well for now. Let's say num12 is equals to 20, and I want to uh, right shift 20 by two places. So we saw that the answer was 5, and let's verify this. Yeah, we got an answer of 5. So we were correct. Now the next example that I took was, I am taking a num13 variable and its value was 15, and I want to print uh, I want to print when I am right shifting 15 by one place. So we should get an answer of 7. Let's see if we are correct or not. 7. Yes, we are getting 7. Let's see what we will get when we will right shift 7 by two places. So you know that 2 raised to the power 2 is 4, and 15 divided by 4 is point something. So you should get the integer part out of it, which is 3. Let us see if I am correct or not. 3. You got an answer as 3. So this was all about binary operators, and yeah, right shift is also complete. Just remember this formula. Yes, remember this formula, and you can easily solve any uh, question of right shift. Uh, so we have discussed all the uh, bitwise operators as well. Now there is an important note for you. Uh, the note is all the formulas of left shift and right shift which are discussed are only applicable to positive numbers. This is a very important note that see, we discussed two formulas here, one for the left shift and one for the right shift. This was for the right shift. Uh, this formula was for the right shift. This is only applicable for the numbers which are positive, num. If num is negative, this formula is not applicable. Similarly, in case of left shift, uh, if num1 is negative, this formula is not applicable. So these two formulas are only applicable for positive numbers, but this formula of bitwise note is applicable for all integers. This is applicable for all integers. This was all about bitwise operators. Now at the last I have also drawn a truth table for you to easily remember what exactly bitwise and bitwise OR and bitwise XOR do. See what exactly happens in bitwise AND. So there is an AND operation between two bits. If one bit is 0, another is 0, the resultant bit will be 0. If first one is 0 and second one is 1, the resultant bit will be 0. In the third case, if first bit is 1 and second one is 0, the resultant bit is 0 again. But if both of the bits are 1, the resultant bit is 1. So you can say that in case of bitwise AND, the resultant is 1 only if both of the bits are 1. Similarly, you can see in case of bitwise OR, uh, these are called truth tables. This, this, and this. These are called truth tables. Now, see in case of bitwise OR, what exactly is happening is if you are doing bitwise OR operation between two numbers. So when we are computing this bitwise OR between two bits of a particular number, if both of the bits are 0, the resultant will be 0. If any one of the bits is 1, the resultant will be 1. And if both are 1, then also the resultant will be 1. So you can say bitwise OR gives 0 only when none of the bits is 1. Now let us go to bitwise XOR. So I told you that bitwise XOR is exclusively, I told you that it is exclusively OR. It is exclusively OR. So since it is exclusively OR, it means that it will only result 1 when both of the bits are different. You can see this. When both the bits are same, that is 0 and 0, the resultant is 0. When both of the bits are same, that is 1 and 1, the resultant is 0. But when both of the bits are different, suppose 0, 1 or 1 and 0, the resultant will be 1. So you can uh, learn this table or easily understand the logic behind them. Uh, this is good for your revision. At last, uh, I have a homework question for you. So the question basically is you have to calculate the circumference and area of a circle, and you have to display that out on the screen of the user as an output in proper format. Suppose the area is a float, which is a decimal number. So you have to represent a decimal number as the output. And you have to take all the necessary inputs from the user. If you need to take any dimensions from the user as an input, you will take them as input. So you have to solve this question, and I will be discussing this question in the next session, which is our session 3rd. You can comment its answer in the comment box. It is all for today. See you in the next video. If you learned something new today, please like the video, subscribe to my channel, and share it with your friends. Thank you.